The General Dynamics F-111 Aardvark changed aviation history when it debuted in the 1960s as the world's very first production variable sweep aircraft. Developed to meet a challenging joint requirement for a tactical bomber and fleet interceptor, it pioneered the massive steel pivot pins required to cycle wing angles safely in mid-flight. At a fully forward position, the main wings generated immense lift for short runway takeoffs carrying heavy payloads. When fully swept back, the jet transformed into a sleek, supersonic arrow capable of low-altitude terrain following dashes at Mach 1.2. The General Dynamics EF-111 Raven took the proven aerodynamic foundation of the original Aardvark airframe and heavily modified it into a dedicated tactical electronic warfare platform. Entering service during the early 1980s, this specialized variant retained the core variable sweep wing design to ensure it could keep up with supersonic strike fighters during complex penetrations. It automatically adjusted its wings to balance long-endurance loitering outside enemy airspace with high-speed escape dashes when targeted by radar. It stood as a vital airborne jammer until its retirement. The Grumman F-14 Tomcat is an iconic carrier-based fleet defender designed to protect US Navy strike groups from massed cruise missile attacks. Entering service in 1974, its standout feature was a fully automated, computer-controlled variable sweep wing system. The central air data computer continuously adjusted the wing angle between 20 and 68 degrees based on Mach numbers, optimizing lift and drag seamlessly during tight dogfights. This meant the Tomcat could achieve incredibly slow landing speeds on short carrier decks, yet instantly sweep back for a Mach 2.3 intercept. The Panavia Tornado was a triumphant multinational European project designed to handle low-level strike, reconnaissance, and air defense roles across 3 different countries. To survive the heavily contested airspace of the Cold War, engineers integrated a variable sweep wing mechanism that allowed the aircraft to perform across diverse operational envelopes. Spanning the IDS strike variant, the electronic ECR, and the long-range ADV interceptor, the Tornado relied on manual wing sweeping. This flexibility allowed it to cruise efficiently at low speeds, or tuck its wings back for supersonic dashes. The Rockwell B-1 Lancer is a towering cornerstone of the American strategic bomber fleet, built to penetrate dense Soviet air defense networks at incredibly low altitudes. First flying in its revised B-1 billion configuration in the 1980s, this massive aircraft utilizes variable sweep wings to blend intercontinental range with high survival rates. With its wings extended forward, the Lancer can take off from shorter runways while packed with dense payloads of heavy munitions. Sweeping the wings fully backward enables the bomber to skim the terrain at near supersonic speeds, reducing radar detection. The Sukhoi Su-17 fitter was a clever Soviet solution to a common problem, marking the Soviet Union's first operational step into variable sweep aviation. Instead of designing a brand new airframe from scratch, Sukhoi engineers modified the existing fixed-wing Su-7 by adding pivoting outer wing panels. The central inboard section of the wing remained fixed, which significantly simplified the manufacturing process and minimized weight penalties. This configuration successfully halved the fighter's takeoff distance, provided better low-speed handling, and kept high-speed performance intact. The Sukhoi Su-20 Fitter C represents the primary export variant of the advanced Su-17 series, tailored specifically for Warsaw Pact nations and Middle Eastern allies during the Cold War. It retained the distinctive, partial variable sweep wing design, where only the outer portions pivoted on heavy mechanical bearings. This layout gave export customers an affordable ground attack platform capable of operating from rough, unpaved forward airstrips with heavy weapon loads. It was a rugged engineering compromise that proved highly successful across decades of global operational use. The Sukhoi Su-22 fitter stands as the ultimate, most refined export evolution of the long-running Soviet variable sweep attack family. Upgraded with a more powerful Tumansky engine and advanced avionics, the airframe kept its signature hybrid wing design to maximize frontline flexibility. Pilots could manually select 3 distinct sweep settings to match their specific flight profile, whether climbing out from a short combat runway or diving on a target. It offered an ideal blend of easy maintenance, low landing speeds, and decent transonic performance across global battlefields. The Sukhoi Su-24 Fencer is a rugged, all-weather Soviet tactical bomber designed to mirror the low-altitude penetration capabilities of the American F-111. Entering service in the mid-1970s, it featured a sophisticated variable sweep wing. With 4 distinct preset angles, a 16-degree sweep provided maximum lift for heavy takeoffs, while intermediate angles optimized cruising efficiency. For high-speed supersonic flight at sea level, the wings swept to 69 degrees. This advanced mechanical system transformed the Fencer into a highly survivable, hard-hitting strike platform. The MiG-23 Flogger was designed to replace the legendary MiG-21 by introducing massive upgrades in radar range, weapon payload, and pure top speed. As the first mass-produced Soviet fighter to utilize a variable sweep wing, it allowed the pilot to manually select 3 primary sweep angles depending on tactical needs. A low sweep angle was used for landing and efficient cruising, an intermediate setting handled agile dogfighting, and a full sweep unlocked blinding Mach 2.3 performance. It became the backbone of the Soviet tactical air fleets for years. The MiG-27 Flogger is a dedicated ground attack optimization of the older MiG-23 fighter airframe. By removing the heavy, complex variable intake ramps and interceptor radars, engineers created a simplified armored strike jet. It retained the robust variable sweep wing mechanism of its predecessor, which gave low-altitude mud movers the ideal aerodynamic profile. This allowed the jet to loiter over front lines at slow speeds while searching for targets, then sweep its wings back to escape at high speeds over hostile territory after dropping ordnance. The Tupolev Tu-22M Backfire is a highly formidable strategic maritime and land attack bomber that sent shockwaves through Western naval commands during the Cold War. Designed to hunt down American aircraft carrier groups with heavy anti-ship missiles, this massive bomber relied heavily on its variable sweep wing layout. The aircraft adjusted its wings to glide efficiently over long distances during transit, then swept them back to launch supersonic dashes toward target zones. It remains an active, long-range asset capable of hitting targets far beyond national borders. The Tupolev Tu-160 Blackjack is the largest and heaviest supersonic combat aircraft ever manufactured, acting as a key pillar of Russia's strategic nuclear triad. Entering service in 1987, this massive bomber utilizes variable sweep wings to achieve an astonishing blend of long-range intercontinental cruise and Mach 2 performance. The enormous wings seamlessly transition across 3 main positions, optimizing the aircraft's lift profile from low-speed takeoffs to high-altitude supersonic dashes. It stands as a masterclass in scale engineering and variable geometry,